Hi guys, sorry again that I couldn't be here today. Here's your lesson. What we're going to talk about today are the properties of trapezoids. So we have talked about quadrilaterals this unit, and we've talked about parallelograms and all the special types of parallelograms, but not every quadrilateral is a parallelogram. So we're going to talk about the trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel lines. Parallel sides are called the bases. So on this picture here, the two sets of parallel lines, or the set of parallel lines, is the base. So we can say these two lines are both bases and parallel. The non-parallel sides are called the legs. And that's the other sides here. So this here is a leg, and this side here is a leg. So we have base angles in trapezoids, and the base angles are consecutive angles whose common side is a base. So both of the highlighted lines are the bases. The base angles would then be the two angles, consecutive angles right after each other that share the side that is the base. So here you have two sets of base angles. Since one pair of opposite sides are parallel, what is true about the consecutive angles whose common side is a leg? So we would talk about this angle here and this angle here. Those are consecutive angles that share a leg. What we know about that is those two angles are supplementary. So they add up to 180. There's different types of trapezoids. One is the isosceles trapezoid. Now if you think back to the isosceles triangle, that's where two sides are the same length, you have one base. Here, a isosceles trapezoid is if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So that would mean that these two angles would be congruent. So angle D is congruent to angle C, and angle A would be congruent to angle B. Consecutive angles that share a base angles. So those are congruent if this is an isosceles trapezoid, excuse me. So here's an example. It says find the missing angles. Notice here we have an isosceles trapezoid where the base is BA and CD. It's just kind of flipped. So since this is an isosceles trapezoid, we know angle C is congruent to angle D. Therefore, angle D has a measure of 100 degrees. We also know that B and C are supplementary. So how we would find B is you would take 180 and subtract the 100 that we already know to get 80 degrees. This tells you the measure of angle B. B and A are also a pair of base angles, so they would be congruent as well. So A would be 80. If a trapezoid have one pair of congruent base angles, then the trapezoid is an isosceles trapezoid. So that being said, if you have one pair of congruent base angles, then we can assume that this is a trapezoid that's isosceles. So here's an example. It says find the value of A so that PQRS is an isosceles triangle. That's supposed to say trapezoid. I apologize. So what we would do is we know that P and S are congruent because this is an isosceles. So we can set those two equal to each other. If we get everything to one side, we can solve this using a vector box. So we would have 0 equals a squared minus a minus 42. So we have to figure out what multiplies to negative 42 and adds to negative 1. Negative 6, 7, and 6 do that. So we would solve saying a minus 7 and a plus 6. When you solve using ZPP, you can have two answers. A is 7 or a equals negative 6. Here's another property. It says a trapezoid is isosceles if and only if, remember this has to happen, if the diagonals are congruent. So if your trapezoid's diagonals are not congruent, then it is not an isosceles trapezoid. So what we have to know is that AC has to be congruent to BD. So here's an example. We have AC equals 12x minus 11 and BD equals 9x minus 2. It says find the value of x so that ABCD is isosceles. So we have to find out what value of x makes these two diagonals equal. So set them equal to each other. When you solve, you are finding the value of x that would create AC and DB to be congruent. So x would be 3. A couple more properties. We talked about mid-segment of a triangle. We also have mid-segment of a trapezoid. It is the segment whose endpoints are the midpoints, remember the middle of each point, of the legs. So x and y are both midpoints. Therefore, when you connect them, you make the mid-segment. The mid-segment of a trapezoid is parallel to each base. So that means that all three of these lines are parallel. The length of the mid-segment of a trapezoid is half the sum of the lengths of the bases. What that means is BC is technically one base, AD is a second base. The mid-segment, that red line, is half the sum of base 1 and base 2. So here is an example. Here we have a trapezoid with 7x minus 4 as your mid-segment. We need to know the length of it. We know that the length of the mid-segment is equal to half of base 1 plus base 2. 38 being base 1, 6x minus 6 being base 2. If we were to distribute the 1/2 in, we would be left with 7x minus 4 equals 32. I lied, that's not 32. Excuse me. I guess I messed up. Ignore the distribute. You need to combine like terms first. So 38 minus 6, that's where I found 32. So it would be 6x plus 32. Excuse me again. Now distribute. 7x minus 4 equals 3x plus 16. When we solve x, you have to get everything to one side. Your x's to one side, your numbers to the other. So that would be 4x equals 20. When you divide by 4, x is 5. Okay? What we're asking for not is the value of x, but the length of the mid-segment. So go ahead and take that x equals 5 and substitute it in. And so you have 35 minus 4, where your mid-segment is 31. What I want you to do at this point is you can work alone and try the next 5 problems. Once you have completed the next 5 problems, go check with the sub, and they will check your work and give you the homework. The homework is due tomorrow. I hope you have a great day, and I'll see you tomorrow.